In the same way that we can do operations on real numbers, we can also do operations on sets, and that's what we'll study in section 2.3.2. In this section, we will learn about set complement, intersection, and union. These are operations specific to sets. Let's begin with the set complement. Notice the spelling here, the set complement. It has an E, not an I, like you look nice today, but it's a set complement. The complement of set A, denoted A prime, is the set of all elements in U, not in A. So again, when I see this apostrophe out here in mathematics, we read it A prime. And it's always going to connect us with this word, not. So A prime contains all of the elements in the universal set that are not in set A. To see how this works, consider example 2. Let U, remember that's our universal set or the frame of reference for the problem. Let set U contain letters A, B, C, D, E, F, G, H, and I. And define set A, which is a subset of our universal set, to contain letters B, C, F, and I. Use a Venn diagram to find A complement and then express A complement in roster notation. So if this is our universal set, notice we're going to name our sets with capital letters and the elements of our sets are lowercase letters. That'll help you to sort out this alphabet soup here. A is a subset of our universal set U. So we're going to go ahead and label this set A. The elements that belong to A, I'm going to switch colors so we don't mix up all these letters here. The elements that belong to A are B, C, F, and I. So we have drawn those elements within circle A to show that they belong to set A. Now, the universal set has more elements. The universal set has also letter A. B is in the universal set, but notice B already lives within circle A. C also lives within circle A, so I don't need to list it again. We also have set D, E, F is accounted for in set A, G, H, and I is accounted for in set A as well. Now that we have used this Venn diagram to visually organize the information, we can identify the elements in set A complement. Remember, A complement represents all of the elements in the universal set that are not in set A. Thus, we can list the elements in set A complement in roster notation as A, D, E, G, and H. So notice there I am identifying all of the elements in the universal set not in A. Complement always associates with opposites or not. Keep in mind, everything that we learn in set theory in Chapter 2 will also apply to what we learn about logic in Chapter 3. So I advise you to master these skills now, and you'll be set and ready to progress in the next chapter. Let's try another example. Example 3. Let U, our universal set, contain elements 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we're dealing with a frame of reference of numbers this time. And define set A to be the set of all x, such that x is an element of the natural numbers, x is even, and x is strictly less than 6. Use a Venn diagram to find A complement, and then express A complement in roster notation. Remember, U is given in roster notation in this case, and A is given in set builder notation. To see the specific elements of A, it might be helpful to translate A out of set builder notation into roster notation. Let's just identify the specific elements that belong to A. First of all, we're dealing with natural numbers. Those are our counting numbers, so we can rule out negative numbers. Also, set A says that the elements have to be even, so that can rule out the odd numbers, and the numbers have to be strictly less than 6. That does not include 6. So looking at our universal set, picking out the counting numbers that are even and less than 6, that would contain just two values, 2 and 4. Remember, we're dealing with natural numbers. Natural numbers are counting numbers, and when we count, we start counting with 1, 2, 3. So 0 is not a natural number. Now, on our Venn diagram, we can illustrate this in a visual way. Our universal set will be every point within that rectangle, and then we're going to put all of the elements of set A inside this circle. So let's start with the elements of set A. A contains elements 2 and 4. Those are the only elements that we're going to put inside circle A. Every other element in the universal set will go outside of circle A. So we have values 0, 1, 2 is already accounted for inside circle A, 3, 4 is already accounted for inside circle A, and then 5, 6, 7, 8, and 9. So again, a Venn diagram is just a visual way of representing the elements and relationship between sets. Now we are ready to identify the elements in A complement. Remember, A complement will contain all of the elements in the universal set not in A. So I'm going to list all of the elements outside circle A. These are 0, 1, 3, 5, 6, 7, 8, and 9. So there is A complement in roster notation. So that's one of our simplest operations. We're simply comparing the set A with a frame of reference in the universal set U and looking at all of the elements that are in the universal set that are not in A. The next operation is called intersection. Now, we've already learned a lot of symbols in Chapter 2. We're going to add a few in this section. Definition. The intersection of sets A and B, denoted A, we read it intersect B, is the set of all elements common to both A and B. Now, if we want to get technical, we can say that is A intersect B equals the set of all x such that x is an element of A and x is an element of B. So make a note that intersection, which is represented with what looks like an upside down U, represents intersection, and it goes with the word and. Just a sneak preview, in the next chapter we'll be studying logic. We'll have a similar symbol to coordinate with the word and. Let's apply this to our sets. Let U, the universal set, contain elements 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now we're going to define two subsets. Set A contains values 1, 2, 6, and 8, and B contains values 2, 3, 7, 8, and 9. Construct a Venn diagram to represent U, A, and B. Then find the requested sets in roster notation. So remember, roster notation simply means we're listing all of the elements separated by commas within curly braces. So on our Venn diagram, the rectangle, every point in the rectangle represents a member of our frame of reference, our universal set. We're going to have two subsets this time, sets A and B, and we're going to draw them so that they overlap so we can illustrate what they have in common. So I'm going to name the set on the left A and the set on the right B. Now let's list the individual items. Set A has values 1, 2, 6, and 8. Set B has values 2, 3, 7, 8, and 9. Now, if I compare sets A and B, they have some elements in common. So looking at set A, 2 belongs to both set A and set B. So 2 is going to be in the intersection of those two circles. We can see where I've written the 2. It's within the boundary of circle A, and it's within the boundary of circle B. So that shape in there in the middle is called the intersection of those two sets. Also, again, comparing sets A and B, we observe 8 belongs to set A, and 8 belongs to set B. So we're going to put that element also in the intersection. Now, looking at sets A and B, they don't have anything else in common. So back to set A, let's complete the circle. The other elements in set A are 1 and 6. They're going to be inside circle A, but outside circle B. Also, looking at the remaining elements in set B, we have 3, 7, and 9. They're going to be inside circle B, but outside circle A. Recall that the universal set contains the digits from 0 to 9. So there's a few of those values that have not yet been placed on the Venn diagram. Everything in circle A and B is accounted for, so let's figure out what's left in set U that is not in set A and B, and we'll place those outside of circles A and B. So we have 0, 1, 2, 3, and then 4, 5, 6, 7, 8, and 9 are all accounted for. So again, the Venn diagram is just a spatial way to represent all of these elements and how they relate to each other. Now, using the tool of the Venn diagram, we can figure out the following sets in roster notation. The first one is A intersect B. Remember, the intersection of two sets contains elements common to both A and B, and I can see those here in the overlap between those two circles. So if we list this in roster notation, the intersection contains elements 2 and 8. Make sure you do draw the curly braces, include commas between your elements so that you have proper notation. The next set is A intersect B complement. So remember, the complement is everything outside of the intersection, everything that is not in A intersect B. We determined that A intersect B is 2 and 8, so we're going to list everything in our universal set that is not 2 and 8. So that's 0, 1, not 2, 3, 4, 5, 6, 7. I'm going to skip 8 and 9. So notice we have listed everything except the elements in the intersection. Let's work on A complement next. We're going to write all of the elements in roster notation that are outside of circle A. So I'm keeping my eye on circle A here, and I want to stay outside of that boundary there. So this is going to contain, I'm going to try to put these in order here, 0, 3, 4, 5, 7, and 9. So again, those are all the elements that are outside circle A. To find B complement, we're going to list all of the elements that are outside circle B. So I'm going to keep my eye on the boundary for circle B. So I'm thinking about everything. I'm going to leave out everything inside this circle. So we'll start with values 0, 1, not 2. 2 belongs to B, 3, and then 4, 5, and 6. So those are the elements that are outside of the boundary for circle B. Okay, now that we have A complement and B complement figured out, we want to now find A complement intersect B complement. Remember, intersect represents the word and. I'm looking for what those two sets have in common. So I'm just going to compare these two sets that we have listed in roster notation and list the elements that they have in common. So again, looking at these two right here, they have a 0 in common, 4, and 5. So A complement intersect B complement, again, is what those two sets have in common. All right, you ready for this one? A complement intersect B complement, complement. So right here, A complement intersect B complement, what we have in parentheses, that's what we just found right here. Okay, so this set in parentheses contains all of those elements. I want the complement of that. That means I want everything not in the set that we just listed. So we're going to list everything except 0, 4, and 5. So 0 doesn't get listed. 1, 2, 3, skip 4 and 5, 6, 7, 8, and 9. Next example, A intersect the empty set. So this means I'm looking for what does the set A have in common with the empty set. Remember, the empty set is empty. It has no elements, which means it has nothing in common with A. If it doesn't have anything, it can't have anything in common with A. So A intersect the empty set is empty. And the same thing is true for B intersect the empty set. The empty set and B have nothing in common, so the intersection of any set with the empty set is always the empty set. Okay, that completes complement and intersection. Let's move on to our next operation, which is union. Definition. The union of sets A and B, denoted A union B, that's how we read it, A union B, is the set of all elements in A together with the set of all elements in B. We could say united with the set of all elements in B. So I'm going to take everything in A and put it together with everything in B. So if we were all in a classroom together, we imagine ourselves on campus in a classroom, there might be a class next door. If all of our classes came out in the hall and joined together, we would unite our two classes. To define this in set builder notation, we could say A union B is the set of all X such that X is an element of A or X is an element of B. So our union symbol looks like a U and it corresponds to the word or. Remember, compare that with our intersection symbol. Our intersection symbol looks like an upside down U and it goes with the word and. It is the overlap between two sets, whereas our union symbol looks like a U and it corresponds with the word or. That's going to be everything together in both sets. Let's clarify this with an example. Let U, our universal set, contain letters A, B, C, D, E, F, G, H, I, J. Define set capital A to contain elements A, C, D, F, I, and B to contain elements B, C, F, I, J. Remember, the capital letters name the sets. The lowercase letters are the elements or the members of those sets. Construct a Venn diagram to represent U, A, and B. Then find the requested sets in roster notation. So as always, our universal set U is framed by this rectangle. We've got two subsets, circles A and B, and we're going to construct them so that they overlap. That way we can illustrate what they have in common. Now, let's look at sets A and B. I'm going to fill this Venn diagram out from the center, working my way out. So the first thing I need to do is figure out what A and B have in common. If I look at sets A and B, just in roster notation, I notice that they both have element C, they both have element F, and they both have element I. So C, F, and I must go in the overlap between those two circles. Those three elements are within the boundary of circle A, and they are also within the boundary of circle B. So those are the elements in the intersection. In fact, we have A intersect B right here. We could go ahead and list that in roster notation as elements C, F, and I. Now be very careful of your notation. Make sure you have the curly braces framing your set and those three elements separated by commas. Okay, let's complete set A. In set A, we've already accounted for the location of C, F, and I. The other two elements are A and D. They're going to be inside circle A, but outside circle B. Similarly, in set B, we have leftover elements B and J. They are going to go inside circle B, but outside circle A. The last thing we need to check for is to see if there's any other elements in the universal set U that are not accounted for. So I'm just going to go through the alphabet. A, B, C, D. Looks like E is missing. So E is going to go outside circle A and B. F, G is missing. H, I, and J. So again, I'm just naming the elements of U as I'm looking at the elements already accounted for in circles A and B, and writing them down outside of circles A and B if they are not already accounted for inside those two circles. Once you have your Venn diagram organized, then it's pretty simple to do the operations on the sets. Let's do our first example, A union B. We're dealing with union, so I'm going to unite the two sets like I'm uniting two classes together. I'm going to put everything in A together with everything in B and just list one big set. And I'm going to try to do it in alphabetical order. So we have A, B, C, D, E doesn't count, F, G, H, I, and J. So to show you where I'm looking here, I'm taking everything inside circle A and B, uniting it together in one set. So the union is everything in both sets, whereas the intersection is simply the elements that they have in common. Let's work on A complement. Remember, to find A complement, I'm going to list everything on the Venn diagram that is outside of circle A. And I'm going to try to do it in alphabetical order. So looking outside circle A, we have B, E, G, H, and J. Similarly, to find B complement, I'm going to list all of the elements on our Venn diagram that are outside of circle B. Now, if you could see me, I'm placing my finger over circle B. Maybe do that on your notes as you're following along. Take your thumb, your big thumb, and cover up circle B so you can't even look at the elements there. And then list everything outside of circle B. So we have A, D, E, G, and H. Okay? Next, let's find A complement union B complement. So I'm going to take everything in A complement together with everything in B complement and unite those two sets and list them in roster notation. So this would contain elements A, B, D, E, G, H, and J. Okay, so everything together in both sets. Guys, I have a typo here. I'm sorry. Change the next operation from union to intersection. So next we want to find out A complement intersect B complement. Remember, A complement union B complement, I just joined those two sets together to form a bigger set. For A complement intersect B complement, I'm trying to figure out what those two sets have in common. So I'm going to glance over the two sets that we have listed already in roster notation, and I'm going to identify what their common elements are. It looks like we have three elements in common, E, G, and H. So for union, we put everything together in both sets. Think unite the two sets. For intersection, I'm looking for what elements did those two sets have in common and listing just those elements. Next, we have A union empty set. So I'm going to take all of the elements of set A and unite them with nothing, right? Now remember, up here we said A intersect the empty set or B intersect the empty set is empty because every set has nothing in common with the empty set. However, if I take a set and unite it with the empty set, I just get the set itself. B union the empty set then would also be B. So the operation makes a big difference. Now, you are familiar with operations of real numbers. When I write something like this, you recognize that symbol, and it tells you a certain way of combining those two elements. If I change that symbol, it gives me a different answer. This symbol represents a certain way of combining those two elements. In the same way, we're looking at operations on sets. When I see this symbol, it is a clue. It is a coded set of instructions that tell me how to combine those two things. And when the symbol changes, it tells me a different way of combining those two elements. So it's important to recognize those symbols and be able to associate it with the correct procedure for combining the elements in those two sets. So complement, intersection, and union are our set operations. And again, we will see these in Chapter 3 in logic.